Section 9.5 has two new rules for how we find derivatives, and it's derivatives of more and more complicated functions. So just to review, we have two basic rules. We have a 5x cubed, or x to the n rule. That'd be 15x squared. And then we have an e to the x rule, where the derivative is itself. And then using those two basic derivatives, we can add or subtract. These are derivatives. We could add or subtract to get 15x squared minus 9e to the x. Today's question is, what if we had multiplication between the x cubed function and the e to the x instead of subtraction? Or what if the two functions were connected by division? You need completely different formulas for this, and they're not what you would expect. So here we go. I'm going to start with something more complicated, and then we'll simplify it down to what we're looking at. It just seems to work easier. I'm going to take three functions multiplied together. In our example, we only have two functions. But if we had three functions, here's how you take the derivative. You take the derivative of the first function multiplied by, keep each of the other two functions the same, and they're all connected with multiply, plus, now you keep the first function the same, do the derivative of the second function, keep the last function the same, plus, then you keep the first two functions the same, and take the derivative of the third function. So one by one, you took the derivative of one of the functions and kept the other two functions the same. So to simplify that, what if you only had two functions multiplied together? For the derivative, take the derivative of the first function times, keep the other function the same, plus, always a plus connecting these pieces, then you switch it. You keep the first function the same times the derivative of the second function. Let's try that on our example problem. I'm going to color code this. F of x is going to be purple, and g of x is going to be blue. The derivative would be, I want f prime of x times regular g of x as it is, plus, keep f the same, times, take g's derivative. F prime of x, take just the purple function, derivative 15x squared, times, second function as it is, e to the x, plus, keep the first function as it is, 5x cubed, and then take the derivative of the second function. The derivative of e to the x is still e to the x. So this is the derivative. Let me just warn you that WebAssign is going to factor out the e to the x. That's 15x squared plus 5x cubed, e to the x. And there's just a thing in math where e's come last. So polynomials come first, and we tend to put e's at the back. But WebAssign will still accept your answer if you multiply the e to the x in the front. Some of you will be wondering, well, could you also, why don't you factor out a 5 and an x squared? You can. You could factor out a 5x squared. That would leave 3 from the first term plus x from the second term, and then have your e to the x. But it turns out that this is harder to work with, so we don't usually do that. We just keep the e part factored out, and we keep the polynomial part all together. But WebAssign will accept any of those formats. Let's try it again. I have a function, and it is the product of two smaller functions. So I have the first function, which I'll call f, and the second function, which I'll call g. And then I have the rule for how you take a derivative. And I get the derivative of just the first function, 3x squared, times g as it is, 3x squared plus 10. And to this addition sign, take the first function as it is, x cubed minus 5, times by, take the derivative of the second function, which is 6x. Then I can FOIL that out, 9x to the fourth plus 30x squared plus 6x to the fourth minus 30x. The simplified version of my derivative is 15x to the fourth plus 30x squared minus 30x. Is there a common factor in here? Yes. Do you need to factor it out? No. But if you wanted to, 15x common here would leave an x cubed. 15x pulled out there would be plus 2x and minus 2. WebAssign will take both formats, but again, this one's harder to work with. So we don't usually simplify it to this factoring point. We keep it expanded out. Now, just for the record, you have options here. So this could be done with the product rule, and here's your answer for the derivative. But you could also decide that you want to exercise the rules of math, the rules of algebra, to say that you're going to do a rewrite. So we're going to FOIL first and get 3x to the fifth plus 10x cubed minus 15x squared, and last would be minus 50. That's still my original regular y, but now I could take the derivative just going term by term, because now it's not a product rule anymore. The derivative would be 15x to the fourth plus 30x squared minus 30x. Hey, look, the same thing. So you have your choice. If it's possible to FOIL it out, you can FOIL it out first. But remember the last problem that we did, 5x cubed e to the x, there's no way to rewrite that. So this one must use a product rule. So this is a WebAssign homework problem. Find the indicated derivative. Notice that they're using the Leibniz notation, dy dx. So I want the derivative of 5e to the x times x cubed plus 1. I have to recognize that that's a product. So I have a first function and a second function. Derivative will be derivative of the first function itself times second as it is plus, then you switch. You take the first function as it is times the derivative of the second function. Now it's a little bit tricky on these just to figure out whether you took the derivative of the e thing or not, because it looks the same. See, whether it's f prime or f, you still got a 5e to the x. The g, original function, looks very different than the g prime. And then I can clean it up. I've got an e to the x in common. I might as well take the 5 with it. 5e to the x. And then from the first term, I'm left with x cubed plus 1. Here's my plus sign. From the second term, I'm left with 3x squared. Perfectly fine answer. Now, didn't I just say that you're supposed to factor it out to the right-hand side? Yes. Also a perfectly fine answer. WebAssign will take either one. Next problem, we have a travel agency, and they plan a group tour for groups of size 35 or larger. If the group has 35 people, there's a baseline cost of $390 per person, but each person's cost is reduced, in this case by $10 for each additional person above the 35. This is like the skating rink problem, except you have $10 reduction for every person. The revenue is given by, now they handed us the revenue, but I just want to go back through how you build this. Just in case at some future point you have to build it yourself. You have a baseline price, which was $390. You have a baseline quantity, which was 35 people. And then X is the number of additional people above 35. So like the apartment buildings, like the skating rink. So $390 minus $10 per extra person. 35 people plus 1 person per increase. Notice that that's the function that they got. Okay, this is a product rule. So to take the derivative, I could use a product. Derivative of the first is negative 10 times, keep the second function exactly as it is, 35 plus x. halfway done, plus, keep the first function as it is, times, take the derivative of the second function. Derivative 35 is 0, derivative of 1x is just 1. Gives me negative 350 minus 10x plus 390 minus 10x. 40 minus 20x, that is revenue's derivative. Okay, now in business, the marginal revenue is defined to be the additional revenue for one more unit sold. And using calculus, the marginal revenue is the same thing as the derivative. It's the instantaneous rate of change of revenue. So here it says find the marginal revenue if the group contains 40 people. So I know I'm doing a derivative because it says marginal revenue. But 40 people, that doesn't mean X is 40. X would only be the number of people beyond 35, so 5 additional people. So I want revenue prime, marginal revenue when X is 5. Go to the derivative function and plug in 5. Gives me 30. And 30 what? Well, this is a revenue prime, which means it's a dr dx. So that's $30 of revenue. That's what R is measuring per. X is an additional person, so one more person. So if you have 40 people and you decide to change it to 41 people, that 41st person will bring in a total of $30 of extra revenue. Okay, that was the product rule for when two functions are multiplied together. Now we're going to have a quotient rule for when you have two functions, function f and function g, and they're dividing each other. Here's what the quotient rule looks like. The derivative is the denominator function as it is times by the numerator's derivative, take away the numerator function times the denominator's derivative. But wait, there's more. All over the denominator function, whole thing squared. And believe it or not, that is the shortcut. Let's look at an example. And I'm going to color code these. I'll make the numerator function, f of x is going to be purple. And the denominator function will be blue. So to take the derivative, g of x, regular denominator, 3x to the fourth minus 1, times the numerator function's derivative, which is 10x, take away, I'm right here, regular f, that's 5x squared plus 6, times the denominator's derivative, 12x cubed. So I've done this part all over the denominator function, whole thing squared. Okay, so far so good, but now we need to simplify, and I want to warn you, see this 3x to the fourth minus 1 and this 3x to the fourth minus 1 that are both in parentheses, and they're both blue, and they look like they should be able to cancel. They cannot cancel because this 3x to the fourth minus 1 is not a factor in the numerator. It's connected with subtraction to this whole other term. You cannot cancel one of those. Instead, you need to distribute. Be 30x to the fifth minus 10x. And now over here, you need to distribute the negative through, but then you also need to distribute the 12x cubed through. I find it easier, since I have the option to multiply in whichever order I want. I'm just going to move this 12x cubed to the front. And then just distribute the negative and the 12x cubed all together. I find it easier to keep track of the negative sign. That will be all over, and then the denominator you never have to FOIL out. You can just leave it as a quantity squared. Positive 30x to the fifth minus 60x to the fifth is negative 30x to the fifth. Then I have minus 72x cubed and a negative 10x. All over my denominator squared. That's how you work a quotient rule. Now you have to do this often enough in this course that you don't want to look up the formula every time. That formula will be given to you in your exam, but still you don't want to have to look it up every time. So here's how I remember it. The numerator function we're going to call high because it's up in the top, and the denominator function we're going to call low because it's down in the bottom. And then we'll color code this. And for our derivative, we have low, then d high. That d stands for derivative. So the low function as it is, g of x, times d high, the derivative of f of x, f prime, minus high d low, derivative of the denominator, all over low squared. Low d high minus high d low, all over low squared. Now some people remember this based off of the high d low. They say, oh, the high d low formula. You know Heidi, Miss Low, Heidi Low, it's her formula. That's okay, but you really need to remember how you start, because since this has a subtract in it, it matters which order you do this in. You have to start with the low d high. It has to come first, and then you subtract the high d low. So I like to remember it based off of you start low. How do you start? You start low. So low d high is how you start, minus high d low. Let's try it again. Given p equals q squared plus 3 over 6q minus 4, so we have a quotient. Find dp dq. So that's the derivative of p with respect to q. Newton would call it p prime, a function of q. That would be, how do we start? Oh yeah, start low. Low d high. Derivative of high is 2q minus high q squared plus 3 as it is, d low, the derivative be 6, all over low squared. Now see again how there's a 6q minus 4 and a 6q minus 4. You can't cancel this because of that subtraction. Instead, we're going to distribute 12q squared minus 8q. And then over here, I need to distribute the negative. I also need to distribute the 6. So I exercise my right to move that 6. And then I can distribute the negative and the 6 together. So negative 6q squared minus 18. All over my denominator, which you can keep in the factored form. 12q squared and negative 6q squared will simplify. Minus 8q minus 18. And you can keep your denominator factored. Okay, a little bit about rules for taking derivatives. If you have two terms and they're added together, then you take the derivative of the first term, derivative of the second term. We've seen that already. We've worked with that. So that would be 3x squared plus, and then the derivative of the second term is 2x. Well, you keep the same logic even if you have the first term, x cubed, second term is all of this together. So the first term I take its derivative, 3x squared, like usual. Second term, I have to do the entire quotient rule just on that. So here my derivative would be my first term, derivative, 3x squared, plus, for my second term, I need a quotient rule. You start low, low as it is, d high is 2x, minus high as it is, d low is negative, let's see that, 0, negative 1 minus 8x. and then that part over low, whole thing squared. So that first term, the x cubed, I just took its derivative, and then when I moved on to the second term, that was the more complicated quotient rule. So 3x squared plus, let me work with this, so distribute the 2x through. Over here, distribute the negative x squared through, makes a positive x squared, positive 8x cubed. This part is over the denominator squared. You do not have to get a common denominator with your 3x squared. That's good news. You just have to clean up this part. So a negative 8x cubed and a positive 8x cubed, those cancel each other. X squared and negative 2x squared make negative x squared plus 2x over my denominator, still in a factored form, still whole thing squared. And type it in just like that. Okay, for our last problem, it's a quotient rule. The high function is e to the x, and the low function is 4x squared minus 15. So notice that either one of them individually is an easy derivative. It's just when you connect them together with division that you have to use that whole quotient rule. So dy dx would be low, d high is itself, e to the x, minus high as it is, e to the x, d low is 8x, all over the low squared. That will make 4x squared e to the x minus 15 e to the x minus 8x e to the x, all over low squared. That's a perfectly acceptable answer. WebAssign will probably factor out that e because that's just the way mathematicians do things. 4x squared minus 15 minus 8x, and an e to the x factored out to the right, all over 4x squared minus 15 quantity squared. Okay, good luck. Send me your questions.